Hello everyone, my name is Konstatin Tennhard and I'm here to talk about simulating and testing third-party service integrations. On the internet I'm also known as T6D, so that's my GitHub handle, my Twitter handle, Instagram. I'm from Toronto, Canada, and just to give you some stats, that's at least a 24-hour travel. I'm going back tomorrow, which is 28, and then it's a lot colder there. It's about minus 20 degrees colder right now, but Canadians still refer to that as a mild winter because it could easily read minus 40. I work for Shopify, and I want to give them a quick shout out and say thank you. Without them, this talk would probably not been possible. They sponsored me coming here, as well as supported me in developing the library I'm actually going to talk about today. There's really 4 libraries that I currently maintain that are of value to know for you from a Ruby development perspective. There's Action Widget, which is a lightweight widgeting system for Ruby on Rails. There's Active Operation, which allows you to break down your Rails application into business processes to extract some of the logic out of the model layer. And then there's Request Interceptor. I won't give any spoilers yet, but that's what we are going to talk about today. And then there is Smart Properties, which I like to refer as Ruby attribute assessors on steroids. They give you type validation, type conversion, default values, and so forth. But let's talk about Request Interceptor. And before we dive into the actual library, let me tell you a little more about the problem I was trying to solve. Managing external dependencies is really hard. What do I mean by that? And what do I mean by an external dependency? For the purpose of this talk, I refer to an external dependency as another application that my application communicates via HTTP with. So there's a couple of challenges around that. Let's start with development. Let's say you're working on your application from a plane. You don't have Wi-Fi, you want to reach out to your third-party service. Well, you can't. That can also become, there's also other challenges around that. Let's say the service you're interfacing with doesn't offer test accounts or any type of sandboxing. If you're talking about a payment gateway, for instance, that can easily become expensive. In production, third-party services are hard to deal with from an infrastructure perspective. There might be errors when you communicate. The network might be temporarily unavailable. How can you ensure that your application actually handles those infrastructure errors properly so that they don't eventually bubble up to the user in the form of exceptions? So this really poses 2 questions. How can we guarantee availability of that service in development? And how can we improve the resiliency of services in production? Luckily, there is one solution to both of these questions that will help us to improve resiliency and also make the service available in development. The solution is to simulate HTTP requests in development and in your tests. 2 of the standard solutions today for doing that are VCR and BAPMOC, but they are highly focused on simulating HTTP requests in your test suites. They also focus highly on simulating individual requests. But what about more complex services? How do you handle that? That's when I basically had the idea, it would be kind of nice to have a Sinatra application that just describes a stub for another service that my application could interface with. And just so I can get a quick show of hands, who in the room is familiar with Sinatra? Okay, that's good. Theoretically, Request Interceptor is compatible with any rack application, so you could write a simulation of another service even as a Rails app, but that can easily get out of hand because Rails apps are a bit more complex than Sinatra applications. You might legitimately ask which HTTP libraries are supported when I use Request Interceptor. And back when I started developing Request Interceptor, the only supported library was NetHTTP. And it took a lot of work to make this work because I was essentially duplicating the work WebMock is doing. And then I dove a little deeper into WebMock. And while it's, I think, not intended to be used as a library by another library, with a little work, I got Request Interceptor to play nicely with MapMock. So now Request Interceptor works with all libraries WebMock supports. Before we dive into the actual code I have to show, let's take a moment to talk about why you should be using Request Interceptor and what it has to offer in comparison to WebMock or VCR. In my opinion, Sinatra is the perfect trade-off between being simple yet powerful. And when you write a Sinatra application instead of having WebMock stubs all over your test suite, the thing you gain is mostly that you can manage these request interceptors in one place. You just have one file per interceptor, per service essentially. And another thing you gain is also the ability to share these interceptors between projects, because you might run multiple projects in your company that interface with the same service. You don't have to do that work over and over again. And finally, and most importantly, in my opinion, the code is just a lot more readable and maintainable over time, as it is centralized, and as I said, Sinatra has a very concise syntax. And then, probably one of the main points of this talk, Request Interceptor can be used for tests and development. And I'll dive into that aspect a little later. So let's quickly look at how Request Interceptor functions from a basic perspective. First, as always, we need to include the library. If you want to use it for both tests and development, you place it into the development and test group. You do the gem include. Once you've done that, you can define an interceptor. And an interceptor definition really is pretty basic. You call request interceptor define. It will return, oh, I'm sorry. It will return a class, and you can simply assign that class to a constant. The define method itself takes a block, and the block essentially defines your Sinatra application. There's a bit of added magic. Sinatra itself doesn't have a host method. I added that method to make it easy to specify which host does the request interceptor actually respond to. And in this case, it accepts either a string or a regular expression. In this example, we use the domain example.com, and the interceptor would intercept any request that comes to example.com or any of its subdomains. And then, using standard Sinatra syntax, we define an HTTP handler that responds to the /hello path if you send it a GET request. And this one is fairly simple. We set the content type to JSON and return an object that has one key value pair, with the key being message and the content being hello Rubyfuza. So that's all you needed to define an interceptor. Now let's look at how we can actually use that. Since we assigned the interceptor to a class, we can call the intercept method on it. And again, the method takes a block, and within that block, any request to example.com or its subdomains is being handled by the interceptor. So this is a rather trivial example, as you could see it in a mini test suite. We fire off an HTTP request, and we simply check that the result is that object we specified earlier. But that's obviously only useful if you would want to validate that your interceptor is handled correctly. Usually what you are after is, did my application perform the requests I expected it to do? For that purpose, the request interceptor keeps a request log. And that is what the intercept method returns. In this example, I omitted the actual HTTP request, but let's assume we made at least one request. Then we get a log of transactions. And any transaction is comprised of a request and a response. And then the request gives you methods like the path, the query, the body that you can assert on. And there's also corresponding predicate method that allows you to quickly check, did the path match a particular regular expression, did the body include a string, and so forth. If you're using RSpec, it is even more convenient because the gem comes with a powerful RSpec matcher. So let's look at a slightly more complex example. And the only reason why it looks a bit clunky is actually because NetHTTP is pretty verbose. All I do here is basically create a new post request and set the content type to JSON, and then assign it a body, and finally fire off the request. Now, if in my tests I'm curious whether this request was executed, I can take the log I captured from the interceptor and say, does it contain the intercepted request? And then I have to specify two mandatory arguments. First, I need to say I'm looking for a post request. This can be post, put, get, delete, and which path I'm expecting the interceptor to hit. Everything else is optional. You can chain on things like, oh, I want to validate that the body that was being transmitted adheres to certain rules, that a certain number of counts of these requests were made. You can validate the query and so forth. And with these chains, the important thing to notice is that they support the standard RSpec submatchers. So here it parses automatic. If it's JSON, the RSpec matcher will automatically parse it for you and actually give it back to you as a hash, and then you can do things like, oh, I expect the content to include a title, but if you go back to the previous slide, it also had some content which is irrelevant for the test here. Furthermore, request interceptors can be customized in your test if you test particular scenarios that only one test is concerned with. Here's a very simple example. Customize itself just yields yet another class that you can assign to a constant. And what we do here is basically we override the /hello endpoint and have it return a French message. Furthermore, if you interface with several services, interceptors can actually be nested. On this slide, the example is I have one interceptor for Shopify, one interceptor for Uber, and then I say whatever block I execute, I want requests to both of these services to be intercepted, and each of these interceptors keeps their own individual request log you can then assert against or use the RSpec matcher to see that your application performed as expected. That's it for the basic usage. So you basically learned how to define them and how to use them in the test suite. But as I said earlier, they can be used in development as well, and I'll get to that in a second. But I want to dive into two other examples first. One thing that's really powerful about request interceptors is they make it extremely easy for you to simulate infrastructure errors. Let's say we define a malicious interceptor that when you invoke the hello HTTP handler actually raises an error. And you might think now for a second, wait a second, how does this work? Usually Sinatra, when it blows up, it renders a nice stack trace in your browser, and then you as a human can basically debug what's going on. The nice thing about Sinatra is that the developers thought of it as it should be embeddable into other applications. And so you can configure Sinatra to disable basically rendering a sec trace, and then you can tell it, if you encounter an exception, let it bubble up. And that's perfect for when Sinatra runs, for instance, within a Rails application, because you want to have the Rails application take charge of the exception handling. But we are really leveraging this fact to have the error actually bubble up into our application layer, where we can now see if our application is resilient against, for instance, the host being not available. Secondly, if you want to craft more complex responses, that's actually an idea a colleague of mine came up with. Instead of hand-rolling your HTTP handlers, he said, we already have all those factories available for creating objects, so why not combine factory bot with request interceptors? And that's actually super trivial, because factory bot already gives you a method that gives you a hash representation of your factory rather than the concrete object. So all you really do is factory bot attributes for, and then you call the factory, and you can generate one large response object, in this case a representation of a shop. While we are at this example, let's briefly talk about how we organize our interceptors. So all of our interceptors live somewhere in the spec support folder. We all put them into one module called interceptors, and then we also have a common base class that just does some Shopify specific things. The important part really is, by putting them in this module and organizing in this way, the code becomes really readable, because now you have interceptors, : Shopify, intercept, do. So even if you are unfamiliar with interceptors, you can kind of guess what's probably going to happen there. Finally, how can we actually use request interceptors in development? Before I reveal that, let me tell you a little story. So at Shopify, most of us work on like a gigantic monolith. It's about 800 engineers, it's millions of lines of code, and we have that one core product where everyone works on. And last year we started to break things apart. We are by no means heading towards a microservices architecture, but we identified like larger chunks where it was clear like they could really live in a separate service. And one of those chunks was the partners dashboard. That's our platform basically for managing partners, affiliates, other developers. And now we took that application out, and one of the problems we had to face was what was previously a simple active record call now actually had to result in an API call. And some of those APIs didn't exist yet because some of the stuff was highly internal. Instead of jumping immediately into building a new API, releasing it and then using it, using request interceptors, we had the ability to actually simulate Shopify as a service in our test suite as well as in development, and experiment with what would a good API look like. How should the partner's dashboard actually interface with Shopify? And while you can do this purely in testing, it's kind of nice if you can spin up the Rails application and have this new Shopify already working, and you can experiment with your application. And in order to do that, you can simply use a rec middleware. And I will eventually add that to the gem, because initially we integrated the support differently, which I will show in a second. But I find the approach using a middleware is actually cleaner. It has one caveat though. A middleware is a fairly easy construct. You simply create a class. Our class keeps track of two things, the Rails application as well as the interceptor we are using. And then when the middleware is initialized, it will always be provided with the app. That's how middlewares work. And then optionally we can supply configuration arguments. In this case, we want to supply the interceptor. And then the executing part of our middleware is fairly simple again. We simply call out to the Rails app, capture the result, and we all wrap this into an interceptor intercept statement so that any call the app makes to a third-party service is captured and redirected to the interceptor. And then because we are not really interested in the log the interceptor produces in a development setting, we just disregard it and we have our middleware return the original result the Rails app produced. As I mentioned, there's one caveat, and the caveat is that it doesn't work with the Rails console. Sure, when you perform a request and you hit a controller and it has a binding price statement, you are within the execution context of an ongoing HTTP request. In this case, the interceptor would be in full effect because you're somewhere down the middleware. But if you boot up your Rails console, the interceptor won't be configured. And you now have to decide whether this is a problem or not. There is a workaround. As I said earlier, request interceptors are rack apps, and webmock can mount rack apps. And that's actually the mechanism I use internally for request interceptor as well. So what you could do is go into your development RB file, require webmock, and then include the webmock API, which is kind of the dirty part because this shows up in other places then as well. You enable webmock and you tell webmock that it is allowed to make other HTTP requests except for the ones that you explicitly stub. Then you call stub request and say any request to example.com you want to be handled by the interceptor, and you're done. And now it works in the Rails server, it works in the developer console, and that's basically how you can use request interceptors in development. Before I end this talk, let me just say that was a lot of content in 25 minutes. If there's any questions, I'm sure that I have at least 5 minutes to take some now, but please also come find me after the talk. You can also talk to me if you're interested in a career change and would like to work for Shopify. We are still massively growing, and that it is from my end. Thank you very much.